This is video number 2 for section 5.6, solving equations with multiple logs. Why did we just cover all that material in the last video about changing something to a single log? Well, it is so that we can solve equations that are a little bit more complicated than we could before, namely equations that have more than one log in them. Now, what I've done over here on the right is I have put the box from the lesson where we first solved equations with logs. These were the steps we followed. We're going to follow the same steps right now. Put the equation in log form, switch to exponential form, and then isolate x. The key is this first part, put the equation in log form. And you might remember what that meant was I had to change the equation so that it looked like this. One log, one base, one result, an equal sign, and a single item on the other side, one power, so to speak. Well, take a look at the left side of this. This is what we've been calling in this lesson a single log, right? Just a log, a base, and a result. Until I can get the left side to look like a single log, I really cannot solve this equation. Take a look at our example. You can see there the left side is very complicated. There's two logs, there's coefficients, there's all kind of stuff going on. I can't solve this unless I can turn that left side into something that looks like this, a single log. Well, we just learned how to do that. It's those three famous rules of logs, and so that's where we start. Just one word of introduction here. If this first part was not here, if this was the equation, just this part that's left, you would get rid of that coefficient the same way we did when we learned this the first time. You would just divide both sides by 2 and it would be gone. But that trick isn't going to work now because now I have 3 terms in all. I have 2 terms on the left and 1 on the right. If I wanted to divide stuff by 2, I'd have to divide everybody by 2. And that would work just fine in a couple of places, but on this first guy, it would make it worse. So that trick is not going to work for us. What am I going to do with that coefficient? Because it is in my way. I do need to get rid of it. Well, we figured out in the last video that if we don't like it there, we can always use that power rule of logs, the one that we wrote backwards, and move it up to that exponent position. Let's do that and then rewrite what we have. Remember, when I move that coefficient up, it applies to the entire result that was previously there. Let's go ahead and simplify that. Log base 4 of 9x squared is what that part becomes, because 3x times 3x is 9x squared. I had to get rid of that coefficient because as long as it was there, I couldn't use that great rule about adding 2 simple logs together. But now I have 2 simple logs being added, and so I can use what we called the product rule of logs. The one that said if you add 2 logs, you can turn it into a single log with the same base. How do you do that? By multiplying the previous 2 result portions together. Notice this equation is systematically becoming simpler and simpler. Let's see, x times 9x squared, coefficient would be 9. X times x squared is x to the third, right? Just add the 2 exponents together. Well, look, I've now accomplished step 1 over here. I've put this equation in log form. It's got 1 log, 1 base, 1 kind of messy result, and 1 power. From this point on, we've done this before. All the rest of this problem is a repeat of the past. Once you're in log form, you simply switch to exponential form. That's following that semicircular pathway around, right? So the base is 4, the power is 2, the result portion is 9x cubed. All that's left now is to solve for x. Let's see, I can simplify 4 squared. This is a power equation, so I need to isolate the base and the power. Let's divide both sides by 9. Now I have x cubed equals 16 over 9. And then to get the x by itself, I will raise each side to the reciprocal power, namely to the 1/3 power. That's as far as I can go by hand. My final exact answer would be 16/9 to the 1/3. We'll have to reach for the calculator to get a decimal approximation. And I got about 1.2114. We didn't have any rounding instructions, so I just went to 4 places. Again, the only new thing in this problem was taking this complicated log expression and rewriting it as a single log so that I could continue on with my process. Let's try one more time. So here's just another log equation. Same direction, solve for x. Again, I can see it's very complicated over here. I have too many logs. I'll never be able to solve this until I get it down to a single log. I can see that subtraction problem in the middle. That reminds me of that quotient rule of logs, but I can't use that yet because the coefficients are in my way. And our trick today for getting rid of these coefficients is to use that power rule backwards. It looks like I'll have to do it twice in this particular problem. So let's use that rule. Remember that 3 applies to the entire previous result. I have x squared now raised to the 3rd power. That's rule of exponents, right? Multiply the powers, so let's do that. Now I have 2 single logs being subtracted. Well, I would like to get that down to 1 single log, and we have a rule for that, right? It's the quotient rule. The quotient rule is the one that says if I have that subtraction problem of single logs, I can create 1 log with the same base by simply dividing the 2 previous results. It has to be the first one divided by the second one. As long as we can simplify that, I think the first part of our process will be finished. This is just simple rules of exponents. Keep the base the same, or rather the base on the top. Subtract the powers. Once again, we've now taken what was a very complicated log equation and we've gotten it down into that log form. 1 log, 1 base, 1 result, 1 power. The rest of this problem we've done before. I'm ready now to switch to exponential form, follow my pathway around there. 7 to the 1 equals x squared. This one's even simpler than the last one. I just have x squared equals 7. To get that x by itself, I'll raise each side to the reciprocal power, namely the 1/2 power. Just a side note, the 1/2 power, you remember, is the same as square root. You may remember from algebra in the past that when you square root both sides, you're supposed to have this plus or minus. We're going to get into that later in the course. The reason we don't have to worry about that here is you cannot stick negative numbers in this position. You cannot take the log of a negative number. So we don't have this issue. Nothing complicated to think about. Our final exact answer is x equals 7 to the 1/2 power. We'll get an approximation off the calculator. And I got about 2.6458 rounded to 4 places. You should use this same strategy anytime you are solving an equation with multiple logs.